We're going to look at some examples from section 7.2, estimating a population mean. This is very similar to section 7.2, which was estimating a population proportion, but there's a couple key differences. So make sure you've gone over the section notes before you try to attempt the homework or any of the problems, so you have a clear understanding of when to use a student T distribution or a normal Z distribution, or whether you can't use either one of those. So this table right here is going to give you the conditions on whether you can use the student T or the normal or neither. If your population standard deviation is unknown and it's normally distributed or n is greater than 30, then you're going to use the student T. If you know your population standard deviation and it's normally distributed or n is greater than 30, then you're going to use the normal Z distribution. If neither of those is true, then you have to use some other method, and we'll deal with that later. But I just caution you, make sure you understand when to use what before you try to do the example problems. So we're going to look at, let's start with number 3 on section 7.2. This is basically asking, do you use the student T distribution, the normal distribution, or neither? So right here it says our standard deviation is not known, and then it shows us this graph. Well, if it's not known, I know I definitely cannot use the normal distribution, so I have to decide if I can use my student T distribution, the T alpha. But by looking at the graph, I can tell that that is not a normal distribution. So this one I'm going to pick neither. It's not normal, or I only have 17 salaries, so because that's not greater than 30, you can't use either one of those. So moving on to number 4, it says, here are summary statistics for randomly selected weights of newborn girls. N equals 151, X bar equals 30.2 Hg, S equals 7.6 Hg. The confidence level is 90%. By looking at just the information they gave me S equals, which is my sample standard deviation. If they give you S and not sigma, you have to use the student T as long as the other requirements are met. So let's check if they are. It either has to be normally distributed or my N has to be greater than 30. So it doesn't say that it's normally distributed, but my N is 151, so that tells me I can use the student T distribution. So now that I've decided what I'm going to use, I'm going to write down all my important information and draw a picture. So N is 151. My sample mean is 30.2, and my sample standard deviation is 7.6, and my confidence level is 90%. So on my bell curve, the student T looks similar to a normal distribution, so you can draw the same picture. It's just a little steeper than a normal distribution, but it's a symmetrical about the mean. So we're going to have an area of 90 in the center, so that means our tails are going to be symmetrical and share the leftover 0.10, so we'll have 0.05 and 0.05. And then you find your T alpha divided by 2 the same way we found the Z alpha divided by 2. You can use your calculator or the StatCrunch. The steps are on your handout for the Chapter 7 formulas. So I'm going to go to StatCrunch, And here you're going to do stat, calculators, and go to the T, because we're doing the student T distribution. This asks for degrees of freedom. Degrees of freedom are your sample size, or n minus 1. So my sample size was 151, so I'm going to put 150 here. And then I'm going to put 0.05 for my area and change that to greater than, and then press compute. So my T alpha divided by 2 is 1.655. I only need 2 decimal places, so